Hello, I'm Dr. Lakshmi Sharma, Assistant Professor in Physics, Brijlal Biyani Science College, Amravati. I welcome to e-class of laser. This class is helpful to students of BSc second year 4th sem. Laser. Laser stands for light amplification by stimulated emission of radiation. In this class, we discuss absorption of light, spontaneous emission of light, and stimulated emission of light. Before start the topic, I want to discuss few things with you. First one, light is a form of energy. Okay, light cannot take any arbitrary values. It must be multiple of photon energy h. One more thing I want to discuss with you, that electron revolves in different orbits. These permitted orbits are characterized by allowed energy level. When electron is in innermost orbit, it has energy state known as lower energy state. It is also known as ground state. We denote it with E1. When electron in this state, it does not radiate any kind of energy. When electron absorbs some kind of energy, it goes to excited state, that is higher energy state. In this class, we denote it with E2. So here we remember three things. Energy of photon is h nu. Lower energy state is known as ground state. Higher energy state is known as excited state. Now let's start the topic. Absorption and emission of light. Absorption. Transition of electron from ground state to excited state. Initially, electron is in its ground state. When it gets energy, it goes to excited state. Lifetime of its in excited state is not so much long. It returns back to its ground state. While returning, that is from transition from excited state to ground state, it emits excess energy. That is known as emission. Hence, absorption means, yes, transition of electron from ground state to excited state. नीचे से ऊपर जाना. Emission, transition of electron from excited state to ground state. Yes, ऊपर से नीचे आना. So, emission means transition of electron from excited state to ground state. As we already discussed, electron cannot stay in outer orbit for a longer time. Its life period in outer orbit or say in excited state is very small. It stays only up to 10 to the power minus 8 seconds. So, electron returns to the ground state. When it returns to the ground state, it wants to get rid of this excess energy. So, while returning ground state to excited state, electron lose its excess energy. This type of emission is known as spontaneous emission. It is responsible for light coming from sun, fire, bulb, candle, etc. Yes, that means when we switch on the light, it is nothing but the electron transit from higher orbit to lower orbit. Electron transit from excited state to ground state. Electron transit from higher energy state to lower energy state emitting photon. In case of a stimulated emission, which is responsible for laser, let's see what happens. An atom in excited state need not wait for spontaneous emission to occur. वो वेट नहीं कर रहा है कि अपने आप नीचे आ जाए. If a photon with energy h nu, that is equals to E2 minus E1, interacts with this excited atom, it can trigger the atom to undergo transition to lower level and emit another photon. It is responsible for light coming from laser source. See, in screen there are three figures. One is for absorption, other two for emission, spontaneous emission and stimulated emission. E1 and E2 lower energy state, higher energy state. So in first figure, electron initially in lower energy state absorbs some external energy and goes to higher energy state. That is known as the absorption. Mathematically, we may write A plus h nu is equals to A star. A, electron or say atom in lower energy state. H nu, external energy in the form of a photon. A star, after absorption, electron with higher energy state. That is absorption. In second diagram, again E1 lower energy state, E2 higher energy state, electron transit from higher energy state to lower energy state, emitting a light of photon. Mathematically, A star equals to A plus h nu. A star, electron in excited state, A electron returns to original state, h nu emitted photon. These emitted photons travels in all directions. Spontaneous emission. It is responsible for light coming from conventional sources of light. In third diagram, we see two photons are emitted. How it is possible? Let again E1 lower energy state, E2 higher energy state. Here external photon is used as a stimulated agent. It triggers the excited electron to come to ground state, emitting a photon. Here photons are multiplied. Mathematically, A star, that is a electron in higher energy state, equals to A, that is electron comes to its original state, that is ground state, plus 2h nu. That 2h nu symbolizes the amplification of photon. In stimulated emission, photons are multiplied. Their characteristics are related to each other. Emitted photon propagates in the same direction as that of stimulating photon. Emitted photon has same frequency, phase and plane of polarization as of incident photon, triggering agent. The light produced in this process is directional, coherent, monochromatic and of high intensity. That is laser, light amplification by stimulated emission of radiation. Laser is directional, coherent, monochromatic and highly intense. So friends, in this class we discuss absorption and emission. Absorption, transition of electron from lower energy state to higher energy state. Emission, transition of electron from higher energy state to lower energy state. Emission are of two types: spontaneous emission as in conventional source of light, stimulated emission as in laser. So we concentrate on stimulated emission, that is transition of electron from excited state to lower energy state with the help of external agent. Here the emitted photon is of same frequency, phase, same state of polarization, highly intense, monochromatic, and that is the laser. So laser, which is highly intense, monochromatic, coherent, unidirectional. Hope you understand. Thanks for watching. If you like, then please share and subscribe my channel. I will catch you soon in my next e-class on population inversion pumping in laser. Till then, bye. Thank you.